Welcome all. Today we are going to talk about arithmetic series and geometric series. So first things first, we need to define a series, and a series is nothing more than the sum of a sequence. So for example, we know that 2, 4, 6, 8, who do we appreciate? 10, 12, dot, 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 is an arithmetic sequence. Whereas if I simply take those commas and change them into plus signs or minus signs, right, because we can have a negative difference, that suddenly becomes an arithmetic series because we are taking the sum of the sequence. So there's a formula which we are going to derive for an arithmetic sum, and it's slightly different than the one the book talks about, or at least the means of derivation is different. The formula itself is the same. I want to pose a question to you. I'm going to ask you to add up all the numbers from 1 to 100, all the integers from 1 to 100. And it's going to take you a little while. So what I'm going to do here is show you a little bit of a shortcut that you can actually add these up in your head. Well, we all know that 1 plus 100 is 101. We all know that 2 plus 99 is also 101. 3 plus 98, 101. 4 plus 97, it's 101. 5 and 96, 6 and 95, 7 and 94, so on and so forth until you get to 50 and 51. Every pair of numbers, there are 50 pairs of numbers that all equal 101. Well, if I have 50 sets of 101, that means I have 5,050 total. Think about how we got that. 50. Why are there 50 pairs? Well, there's 100 numbers divided by 2, because there's 2 in a pair. I took the total amount of terms, n, and divided by 2. Where did I get 101 from? Well, I took the first term, and I took the last term. There's my formula for an arithmetic sum. So S sub n for arithmetic, I'm going to write it slightly different now, is n times T1 plus Tn over 2. The way I like to think of it is it's the average of the terms times the number of terms. Each of these terms from 1 to 100 have an average of 51. Sorry, 50 and a half. That was very dramatic, the 51. Average of 50 and a half from 1 to 100. 101, those two terms average 50 and a half. 2 and 99, average 50 and a half. 50 and 51, average 50 and a half. Okay, it's the average of the first and last term times the number of terms. Example. Let's say you need to add up 5 plus 10 plus 15 plus, let's say, 150, dot, 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 all the way up to 150. Okay, clearly that is a arithmetic series with a common difference of 5. The first term plus the last term, I wrote them opposite, divided by 2. So there's the average of the first and last term. Now the question is, how many terms are there? And that's where we need to go back to our formula. From the first day we had T sub n equals T sub 1 plus D times n minus 1. Well, 150 is my last term. 5 is my first term. The difference is also 5. And I don't know n. Subtract, that's 145, equals 5n minus 5. 150 equals 5n. So n equals 30. So there's 30 terms. So we have 155 over 2 times 30, or if I reduce that, it becomes 15 times 155, and whatever that number is my sum. So we have 155 times 15, 2325 is my sum. Okay, so not too bad there to add up 30 numbers. We added up pretty quickly to get that value. Okay, so again, the formula for your arithmetic series is this guy right here. And likewise, if we have a geometric series, the geometric sum formula. And it's also important to understand that this is for a finite series, one that ends. Okay, the geometric sum, we're not going to derive this one. It's your first term times 1 minus r to the nth power all over 1 minus r. So let's look at 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128 plus 256 plus 512. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. 9 terms. Let's say you didn't know you had 9 terms. We know this is t sub 1. And we know we need an n. So we need to find the number of terms. So t sub 1 is 2. So our formula, remember, is t sub n, so our last term, equals our first term times the ratio to the n minus 1. Well, 512, let's actually divide that by 2 and make that a 256. 256 equals 2 to the n minus 1. Now at this point, you can do logs if you'd like, or you can say, hey, this is a power of 2. This is 2 to the 8th equals 2 to the n minus 1. So 8 equals n minus 1. So n equals 9. Okay, or again, you could have used logs and said that the log of 256 equals n minus 1 times the log of 2. N minus 1 equals log of 256 over log of 2. And that undoubtedly will come out to 8 on your calculator. And n would equal 9. Okay, so back to the formula up here. If I want to add these up, s sub 9, the sum of the first 9 terms, will equal the first term times 1 minus the ratio. My ratio, we can clearly see, 4 divided by 2, 8 divided by 4, 16 divided by 8. My ratio is 2. To the nth over 1 minus 2. So we have 2 times 1 minus, well, 2 to the 9th is 512. All over negative 1. So we get 2 times negative 511 all over negative 1, which equals 1022. So if I would literally add these numbers up, let's make sure we're right here. Clear. 512 plus 256 plus 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2. 1022. There we go. Confirmed. So here is your formula for a geometric series, how to add up a sequence of geometric terms. And as with all these formulas, you can be given the sum and be asked to find the first term. So remember, equations, formulas, they all work in both directions. So keep that in mind as well. That is really all we have for you today, and I hope you have a nice one. We'll chat later.